Hi Algebra 2 people, hope everything is going okay. So today, a little bit heavy, probability, but this is not the simple probability that you guys did when we just looked at the probability of rolling a die, because this is going to involve permutations and combinations. So before we get started though, I kind of wanted to do a little warm-up just to make sure you're good with this. So if you want to take a pause of the video for a second and do these problems on your handout, and then we'll come back and take a look at your answers. So we have 4 of 8 swimmers in a heat advancing to the next round of competition. So number 1 is going to be a combination, because it doesn't matter which 4 they are, we aren't placing them first, second, third, and fourth. So that's going to be 8, choose 4. And when you work that out, that's going to be your 8 factorial over 4 factorial times 4 factorial, which turns into 70. Okay? On number 2, you have how many different arrangements of the letters in the word Alabama are possible. So we know that that's going to be a permutation. So you're rearranging those letters. There are going to be 7 letters in the word, and we actually have 4 repetitions of an A. So we divide by 4 factorial, which leaves you with 7 times 6 times 5, which is 210. And then lastly, number 3, you have which expression gives the result of a 4-digit random number that can be generated using the values 1 through 9. So we have only 9 digits with nothing being repeated. So we have a possibility of 9 in the first place, then there's only 8 left, then 7, then 6, so that's your truncated factorial. But what we want to know is what does that equivalent to. So that's 9 factorial over 9 minus the 4 places factorial. That's your permutation. That's your 9 permuted, 4 different ways. And that represents 9 factorial over 5 factorial, which is A. Okay. So this slide is just kind of over an overarching theme. Probability is, this is our intro to probability section. So the probability of an event equals the favorable outcomes, which we call success, over the total outcomes possible. If you were to look in your book, you'll see that they also label it as looking at the successes over the successes plus the failures, which when you add those together basically means the total possible outcomes. Or you could even be looking at the probability of a failure, which is also what, so basically the top is what it is you're hoping to happen, whether that be a success or a failure, okay? And we've already looked at probabilities. They always fall in a continuum from 0 to 1, including the endpoints. So 0 meaning it's absolutely impossible or never going to happen, and 1 being that it is absolutely certain to happen. And then we have the closer to 0 then is less likely to happen. When you have a 50-50 chance of an event happening, we consider it to be random. So that would be something like the toss of a coin, where you have a 50-50 chance each time. Okay, so now we're going to start looking at some probabilities, and we're going to start with ones that involve combinations. So if you remember that combinations are the looking at how things can be rearranged when order doesn't matter. It just matters how many of something you're pulling out. Okay, so order doesn't matter. So how does this work? Well, Jones has a collection of 32 CDs, and of those CDs, 12 are going to be rhythm and blues, 20 are going to be jazz. So together that makes up his total 32, and he's going to randomly choose 6 CDs to take with him. So what is the probability that he chooses 3 of each genre? So we want to know 3 of the R&B and 3 of the jazz. So the first thing we're going to consider is the success. The success is like what you did yesterday in terms of we want to know how many different ways can he choose 3 R&B from the 12, and how many different possibilities or how many combinations are there of his choosing 3 from the 20 jazz. So that's exactly the 12 choose 3, even though he has a total of 32, we're only picking the R&B from the total set of R&B, and then times, that's your counting principle, of the 20 jazz, he's only going to choose 3. So that represents our numerator. That's the probability of success. So the 3 and the 3 add up to the 6 total that he's going to choose. Now the total sample space is of the whole 32 CDs that he owns, he's going to choose 6 of them. So when we make a fraction out of that, it turns into a probability. So the probability, the success is on the top, that's how many different combinations are possible, over the total combinations given that he has 32 CDs and is going to choose 6 of them. So when you go through and work that out, 12 choose 3 is 220, times 20 choose 3 is 1140, divided by the 32 choose 6 is 906,192. When we make a lovely decimal out of that, we get approximately 0.28, or you could turn that into a percent. That would represent 28%. So he has a 28% probability of choosing 3 R&B and 3 jazz from those 32 CDs. It's pretty low, which actually kind of makes sense. Okay, so now we're going to look at a bag containing marbles. And so we have 1 green, 4 red, 5 yellow. So the first thing we want to know is our total sample space, which is 10. So you have 10 marbles in this bag. And we're going to look at if we reach inside the bag and we're grabbing 2 marbles at the same time. 2 marbles are selected at random, and we want to find the probability of choosing these different combinations. So the probability of choosing 2 red, well, again, our success is going to be, I'm going to have, of the 4, I'm going to choose 2 red, divided by, of the 10, I'm going to be choosing 2 of them. So when we work that out, you actually get 6 out of 45, which reduces to 2 out of 15. Okay, so that's the probability of choosing 2 red out of this bag. Now what's the probability of 1 red and 1 yellow being in our hand? So that's, well, of the red, again, we have 4 reds, so 4 choose 1 times, that's your counting principle. Of the yellow, we have 5, so it's going to be 5 choose 1. And that, again, is over of the 10 marbles, we're going to choose 2 of them. That's our total sample space that we're choosing from. So when we work that out, 4 choose 1 really turns into just 4. 5 choose 1 is going to turn into just 5 over the 45 that we had before. And that reduces to 4/9, since 5 goes into 45 9 times. Okay. And then lastly, we have the probability of 2 green. Well, there aren't 2 green in the bag, so that probability is really easy. It's going to be 0. Okay, so just a quick recap. When you're doing ones that involve combinations where order doesn't matter, you're just going to be grabbing something from a subset and you're looking at the probability. So probability is always going to be a fraction. So it's basically taking what you did yesterday for the numerator. That's the success. That's what you're looking for. And then you're dividing by the total possible that you might have. So yesterday we did cards, and we didn't look at pulling of the 52 cards, getting a hand that had certain criteria, but that's what your your denominator would now be. So now we're going to look at probability involving permutations, which means that order matters. So we can put things in first, second, third, president, vice president, secretary. So however we grab things, the order in which they are put makes a difference. So we have 5 comedians that are going to put on a show: Al, Bob, Carl, Dan, and Eric. So notice A, B, C, D, and E. All right, their order of appearance is totally random, and we want to know what would be the following probabilities. So what is the probability that Bob is going to go second? So the way you look at this, so we have 5 different comedians, so we have 5 different positions that they could fill. We know that success means Bob is in the second place. So we're going to fill that second place already. We know that Bob is going to be there, and that's just set because that's what success means to us. So what's left is we have 4 people that we can place. So in this first place, we have 4 possibilities. In the third place, we're now left with 3 possibilities, then 2 possibilities, then 1 possibility. So that means that what we really have for a success is 4 factorial over the total sample space, which is how many different ways can we permute those 5 people, is 5 factorial. And so what I want you to realize is I have written down here P or NPR, 4P4 and 5P5, but really what does 4P4 mean? It means 4 factorial over 4 minus 4 factorial, which is 0 factorial. So realize that this really just means 4 factorial. This is just another way of writing 5 factorial. And so when you work this out, we have 4 times 3 times 2, etc., over 5 times 4 times 3. So it all simplifies out to there is a 1/5 probability of Bob coming in second, or being put second to perform. Which if you think about it, there are 5 places, and he wants one of them, so it kind of makes sense that there'll be 1 out of 5 probabilities. So that's can be also reasoned out, but I'm trying to give you actually a structure by which you can do these so when it's a little more difficult. So for instance, now we have the probability of Bob going second and Al going last. So we've already filled in these 2 positions. That means success and that means success. So what do we have left? Well, we have 3 possibilities to go here, now 2 possibilities here, and then 1 possibility here. So what does that give me? That gives me success means 3 factorial over the total possible, which is your 5 factorial. So that's going to be your 6 over 120, which is going to be your 1 over 20 possibilities. Okay, so it's a little harder to figure out when you add a twist to it, so we're trying to get at the fact that you can look at these in a very systematic way as a permutation. Okay, so now, this is very real for some of you. You signed up for English. Let's put a little English, pre-calc, Spanish, biology, and history. 5 different courses you're going to take next year. Class schedules are assigned randomly, and you want to know the probability that your first 2 classes, so we're going to put a little line here, that they're going to be pre-calc and biology in any order. So in this case, what does success mean? Well, either of these 2 first places could be pre-calc or biology. I just know that I want them to happen in those 2 places. So in other words, how many different ways can I rearrange those 2 topics for success? That would be 2 factorial. That leaves me with these last 3 places. So for my schedule, I have how many different ways can I permute these 3 would be 3 factorial. So the probability of this event is going to be 2 factorial times 3 factorial for the numerator, and then the denominator is how many different ways can I rearrange 5 subjects, which is 5 factorial. And so when we work that out, again, this is like 2 permute 2, 3 permute 3, which is the same thing as 2 and 3 factorial. We have 2 times 6 over 120, so 12 over 120 is 1/10 probability. Okay? Okay, and lastly, just to kind of help you out, I want to do a couple problems that are actually from your homework. We're going to look at if you have 8 DVDs that cover 1 season of a series. So we're going to map this out. So you have 1, 2, 3, 4, 5, 6, 7, 8. We want to know what is the probability of season 5 being in the correct position. So here's 1, 2, 3, 4, 5. So this position is already taken. That's a done deal. So the probability of success in this case is, well, I have 7 possibilities here, then 6, then 5, then 4, 3, 2, 1. So success would mean 7 factorial for the others, because I've already taken up that 5th position, over the total possible permutations. that would be 8 factorial. So if I work this out, we have our 7 times 6 on down over our 8 times 7 times 6 on down. And notice in this case, because it's only one event, I can look at it as 1 out of 8, which kind of makes sense. So that was sort of like Bob going second before. But as soon as we then start to add more to the mix, it's going to be a little bit harder. So we're going to use the same process though. So now I want to look at the probability of season 1 and season 8 being in the correct position. So here's season 1 and here's season 8. So success means that those two are fixed, they're done. So for the other positions, well, I have 6 seasons left. So I have 6 times 5 times 4 times 3 times 2 times 1. So that's going to be a 6 factorial over our 8 factorial. And when we multiply that out, the 6, 5 on down will have been canceled by the 6 times 5 on down here. So we end up with, I'm going to write it out here, 1 out of 56. Okay, so let's see if we bring a little more to the plate here. What happens if I want to find the probability of season 1 through 4 being in the correct position? Okay, so season 1 through 4 in the correct position. Okay, probability of season 1 through 4 in the correct position means that these are already set. They're in the right place. So what I'm left with is the other 4 videos, 4 times 3 times 2 can 1. How many ways can I permute them? So that's going to be 4 factorial over 8 factorial, which gives me 1 over 1680. And then lastly, we have the probability of the even seasons followed by the odd. So let's get rid of this and see how this would work. Okay, so the even seasons, that's going to be your 2, 4, your 6, and your 8, followed by the odd, which would be your 1, your 3, your 5, and your 7. So how many different ways can I permute these? So the probability even followed by the odd. So I have 4 evens that are going to go first. How many different ways can I permute these as a success? Would be 4 factorial, because I have the 4 different even seasons, followed by 1, 3, 5, 7. I have 4 seasons there, so followed by 4 factorial. So this one's going to be 4 factorial, followed by 4 factorial over your 8 factorial, and that would be reduced to 1 over 70. Okay? So I hope this helps, and today, yeah, you're going to be doing probability with permutations, combinations, and I will have answers posted if you need to take a look. Good luck.